All right, so here we go. Make sure you have your calculators ready to go. I don't know. So these are regressions where points are missing. Okay. And for you, for a quadratic, I'm going to use a different color for this. For a quadratic, you need minimum of 3 points. Maybe I'll say this here on the side. For linear, you need 2 points. Quadratic, you need minimum of 3 points. Cubic, what do you think? 4 points. So you need more than the degree, one more than what the degree is. Okay. Doesn't mean you can't have more. You can go for more if you want to, but you need to, if you're creating your own, that's what you do. So I'm gonna skip quite a few pages because this is essentially copy paste from grade 11. Okay, this slide right here, if you still have your grade 11 books, it will be in there, maybe with a slight variation. So we have essentially, let me see here, we have types 1 to 3. You need to create a table with at least 3 points to perform a regression. And I don't know if you remember the profit revenue type of scenarios. That's the first one we're gonna go through. So I'm just gonna go straight to the example, okay? It's not taking away, it's not like this isn't important the rest here, but I've talked about it last year, so I think we can just go into the example and you will take it from there. So let's go to 46 here and come up with our regression. Okay, so a movie theater charges $1.80 per ticket. At this price, it sells approximately 400 tickets per day. This is on page 46. The theater manager has observed that for every 10-cent increase, this is the key, this is where the change happens. For every 10-cent increase of ticket, there are 40 fewer tickets sold. Right? So you need to make sure that every time you increase the price by 10 cents, you're going to decrease 40 tickets. You're going to sell fewer tickets. Okay. So when you have a question like this, and it's asking you to perform a regression, you want to set up a table like this. It doesn't have to be this fancy. Normally, I have something like this. The province has a table for you to fill in. So what you want to do is, this is the pattern. I usually go with the price per ticket, right? The price is the focus here. Then I will focus on the number of tickets. So it could be number of items, whatever it is, rentals, cookies, cakes, you name it. And then this would be your profit. And the profit is simply multiplying the price by the tickets. So, right, this one I think you should understand, right? Multiplying the two tells you how much you will be profiting. So there's a starting point here, which is, I'm going to go with pink here. If this is the starting point, you sell 400 a day. Okay, so you need the starting point. They need to give you that. So this would be $1.80. You're selling 400 tickets. So the profit here would be $1.80 times 400. I'm just gonna do that here. It's $720 that you'd be profiting under those circumstances. If you now add 10 cents to this, that gets you to $1.90, which means that you would lose 40 tickets, right? You would sell fewer tickets. So there's your $1.90 times 360, 684. So I go 190 times 360, 684. So you're profiting less there, profiting less. But there's a sweet spot, right, where you maximize it. So 10 cents increase again, that gets you to $2 exactly. Hey, guess what? If you do that one more time, you're gonna lose 40 tickets again. Okay, so that gets you to 320. So that'll be $2 times 320, and we can probably do mental math on that one, right? 2 times 320 be 640. So your profit is going down, but hey, these are just the 3 points. You've created 3 points, a table of value with 3 points, and you're like, wait a minute, there's way more than that. What's going on here? Okay. Once you've created this table, you got to be careful. You got to read what it's asking you to find. Determine the equation relating the ticket price. That's what you're going to put into L1, and the profit. The profit is always L2, by the way. That's your Y. So your X is determined, your Y is determined as well. So we go over here to our table. We'll make sure that we say, hey, this column is going to go into L2, and the ticket price. Just pay close attention to this. This isn't fixed. Like you could have had number of tickets first and then the price per ticket next. It doesn't matter. You just have to make sure. In this case, ticket price is the first column for me. So I'm going to put a big L1 there, indicating that I'm using these 2 columns to come up with my quadratic equation. So this would be stat, calc, quadreg. I'm just letting the audience know I'm using quadratic regression. Enter this into your calculators. I'm going to go clear everything. Oops. Here we go. Remember, plot 1 should be turned on if you want to use Zoom 9. I'm going to try it. I'm first going to perform the regression. How's that? There it is. Quadratic regression. Boom. So I'm going to write that down. Negative 400 x squared plus 1120x. And c is 0, as you can tell. Note, A cannot be equal to 0. If you do a regression and this is 0, go back. Your common mistake is L1, L2 because you're so used to L1, L2. If you combine these two, you're getting a linear. That's why it's letting A equal to 0 because it's not a quadratic. Okay. So let's see if we can graph this. I'm just going to go graph, see what happens. See nothing. But I know this is it's a negative, right? So leading coefficient is negative. So I expect this quadratic to do this. So let's zoom in. I'm going to zoom 9 because the stat is going to zoom into these points here. And what you're seeing is the leg coming down, which is normal for that to happen. We're going to change our window real quick. I'm going to let my x min be negative, and I'm also going to let my y min be negative. I want to see the x and the y axis. I want to be to the left of the y axis, underneath the x axis. So let's hit graph one more time. Whoa, overkill, right? This is overkill. So I'm going to go x min minus 1. That's all I'm going to do there. There we go. That's better. So I'm going to increase my y max and my x max at the same time. I'm going to go x max 5, let's say, and y max I'm going to go 1,000. Based on what I had here, that makes sense. So there's your curve. If you want to look at my window one more time, just went -1 for the X-min, 5, and then -10, 1,000. So zoom stat gets you started, and then you have to adjust it as needed. Okay. It's asking what ticket price would result in the maximum profit. What is the maximum profit? This will be found, right? Maximum profit found at the vertex. That's where the maximum profit is located. Like if this is your profit and this is ticket, right? Ticket price, then here, this is the max profit is going to be found right here. The highest profit, the highest Y value is going to be right here. So let's go find the vertex. Second trace 4. I'm going to go to the left of it. I'm going to go to the right of it. There you go. 140, 784. So I know based on this point that a ticket price of $1.40. So you actually have to reduce your price if you want to maximize profit. Isn't that interesting, right? We kept on increasing the price, but you actually have to go all the way down to $1.40 will result in a maximum profit. And because it's asking about it, right, of, in this case, it's a nice round number, it's $784. I will do a D real quick here. How many tickets are you are expected to be sold at that price in C? So what you need to remember for this one is that profit is tickets times price. Okay. In this case, you know your profit. You don't know your tickets, but you do know the price. It's $1.40. So all you have to do, like, don't use your equation because your equation is comparing ticket price and profit, not the tickets actually, right? So we just divide both by $1.40. And so tickets, this will probably give me a decimal. That's okay. I'm almost done. Oh, that's a round number. 560 tickets. If it had been a decimal, you round, right? I'm going to leave it there, but I'll park this here, but I will give you a take-home AC, which is going to be your homework for tomorrow. Okay, so you don't do this, just a take-home AC.